Alright, video solution number 2. If the problem wants us to find the magnitude of the electric field along the z-axis of two rods in the x and y axis. So from class, we got our components here, which we plugged into our equation for the magnitude of the electric field there. And we figured out that this all reduces to -2 y hat lambda over 4 pi epsilon naught times the integral from -1 to 1 of 1 over z squared plus x squared plus 1 to the 3 halves dx. Alright, so there's a simple cancellation there. And I went on to integrals.com and evaluated this integral. And what it actually turned out to be was, copying this stuff back down, it turned out to be this. This was the integral part. Then just plugging in these limits, it ends up being could pull out this z squared plus 1 because x's are variable. And then that ends up just simplifying because this is the same term added together. That just ends up being -y hat lambda over pi epsilon naught z squared plus 1 z squared plus 1 times z squared plus 2 to the 1/2. So that ends up being our magnitude of the electric field that it asked us to find. The next part asked us for z is much greater than 1. Show it asked us to basically just plug in z is much greater than 1 and see that this reduces to a dipole with the appropriate dipole moment. So I'll do that real quick. Alright, so after plugging in z is much greater than 1, the electric field becomes E equals -lambda over pi epsilon naught z cubed y hat. And we needed to show that this agrees with 1 over 4 pi epsilon naught times qd over z cubed. And then knowing, off to the side, knowing the basic formula for a dipole moment, P equals QD. So, what I did was I took these two things and set them equal to each other. And what that ended up giving me, negative lambda over pi epsilon naught z cubed equals 1 over 4 pi epsilon naught times q d over z cubed. Make the cancellations. So pi, basically end up with negative lambda equals qd over 4, and then I get negative 4 lambda equals p, making that substitution there. And after that, to find the other part, to make sure that the two sides agree, using the p equals qd, Q in the case of two rods is going to be lambda times L, so that ends up being lambda times L times D, which lambda is lambda, L in this case is 2, and D is also 2, because the rods are 2 units long and they're 2 units apart from each other. So that ends up making P equals 4 lambda. So we can see that these two sides agree, and the only difference is this negative sign here, and what that's from is just because the electric field, the magnitude of the electric field points in the negative y direction. So that's that.